Good morning, everyone. In this lecture, we are going to discuss about fuzzy logic. So, fuzzy logic is an essential component for soft computing. So, today uh, we will discuss about the basic concept of fuzzy logic, and to understand the fuzzy system, we should familiar ourselves with different terminologies. First one, what is fuzzy? Fuzzy logic is a language, we can say more precisely in a mathematical language, like any language you know. So, this language is also used to express something which is meaningful to others. It is a language, this means that it has a grammar, it has its own syntax, the meaning like the language for communication, like English. Like fuzzy logic, there are many mathematical languages. So one language is called as relational algebra, which is based on the operations on set. So that this is called as an relational logic. And next one is Boolean logic, is basically based on the operations on Boolean variables. It is Boolean algebra. It is also called an predict logic, or it is called the predicate algebra, which is basically operations based on well formulated formula, or proposition, also called the predicate proposition. It is very interesting that fuzzy logic, like relation logic, Boolean logic, and predict logic, it also deals with some elements. The elements on which the fuzzy logic depends is called fuzzy set, and it is also alternatively called the fuzzy algebra. And another interesting fact is fuzzy logic is essential combination of different algebras, like relational algebra, Boolean algebra, and predict algebra together. So basically it is a mixture of different mathematical languages to define another new language. This is called as fuzzy logic. So in dictionary, the meaning of fuzzy is not clear, or it is called as noisy. An example was, if we see one figure in the digital image processing, uh, if the figure is not in a proper or clear in the slideshows, we can say that the picture in the slide is fuzzy. We will say it is not clear. No? Instead of using that word not clear, we are using fuzzy. This is an example, one example for the word fuzzy. Next, crisp or classic sets. So the meaning for fuzzy is not clear, and the meaning for crisp is antonym of fuzzy. So what is the antonym? Not clear. Antonym was clear. So crisp is called as an clear set. All the individuals, it has a two categories. First one is individuals make true the predict, and group 2 is individual make false the predict. So generally crisp set means saying yes or no. These are the two basic logic groups which are used in the crisp sets. Next, crisp relation. It is a relation of fundamental importance in all engineering fields. Basically, relations can be also be used to represent similarity. Relations are involved in logic, classification, pattern recognition, and control. Some relations concern elements within the same universe. One measurement is larger than another. One event occurred earlier than another. One element resembles another, etc. The other relations concern elements from disjoint universes. The measurement is large and its rate of change is positive. The x coordinate is large and the y coordinate is small. For an example, all relations between two objects, but in principle we can have relationship which hold for any number of objects. So the crisp relation is defined as R from a set of A to a set of B assigns to each ordered pair exactly one of the following statement. So the first statement is A is related to B or A is not related to B. So the Cartesian product A cross B is the set of all possible combinations of the items of A and B. For example, when A is equal to A1, A2, A3 and B is equal to B1, B2, which means A cross B is equal to the combinations of all A, B1, A2, B2, A3, A1, B1 possible combinations are called as a Cartesian product. The Fuzzy relations map elements of one universe, say U, to those of other universe, say V, through the Cartesian product of the two universes. However, the strength of the relation between ordered pairs of the two universes is measured with the relationship function expressing various degrees of strength of the relation on the unit intervals 0 and 1. As an example, fuzzy relation, word friend describes the degree of friendship between the two persons. This is an example for fuzzy relation. Next, composition of fuzzy relation. This composition is defined by an inner product. The inner product is a relation R is defined on the sets of A comma B, and another fuzzy relation S is defined on the sets of B comma C. So the composition of defined by the inner product. The inner product is similar to an ordinary matrix dot format, except multiplication is replaced by minimum and summation by maximum. Thus this composition is defined by the followed equation, that is R is intersection to A cross B and S is intersection to B cross C. So the dot matrix, the composition of dot matrix S dot R is equal to SR. Of the two relations R and S, express the relation between A to C. Next, fuzzy tolerance and equivalence relation. A fuzzy tolerance equivalence relation will have the three following matrix relation properties. First one is reflexivity, second one is symmetry, and third one is transitivity. Here the R be the fuzzy relation defined on the set of cities and representing the concept very near. We may assume that a city is certainty to very near to itself. The relation is therefore called as reflexive. Furthermore, if a city A is very near to the city B, then B is certainly very near to A. Therefore, the relation is also symmetric. Finally, if a city A is very near to the city B to some other degree, and the city B is very near to city C to some other degree, it is possible that city A is very near to city C to a smaller degree. Therefore, the relationship is non-transitive. A fuzzy relation is a fuzzy equivalence relation if all three of the following properties for matrix relation defines. So reflexivity, symmetry and transitivity are the three relations. So the tolerance relation has only the properties of reflexivity and symmetry. A tolerance relation R can be reformed into an equivalence relation by at most n-1 compositions with itself, where n is the number of rows or columns.